And when I read the math behind zero knowledge proofs, it took me a while, like a few full days of staying in my man cave and no distraction. And I still couldn't understand like 80% of it. So all that to say, this is really at the bleeding edge of computer science.
And maybe let's go a little bit deeper, just for fun.
Okay. Fun for me, not Smith.
Welcome to Good Game, a podcast for crypto insiders with your host, Imran and Qiao. All right, welcome to Good Game. Today, we're going to be talking about rollups, specifically zero-knowledge rollups or zk rollups and optimistic rollups. And today we have a guest who also works with us. He's our head of research, Mohamed Fouda. And Mohamed Fouda, his background is quite deep. He did his PhD in electrical engineering. He's worked on research within Alliance and also has worked with me on the research side for other venture funds. His background is great because he understands and has built products both from a technical perspective and then also help a lot of our founders in regards to how to think about rollups and kind of their technical strategies moving forward.
Just to add to that, Fouda is also a former founder himself. Basically, all the things you guys have ever heard from me and Imran on the technical side that are interesting and insightful, pretty much all come from Fouda.
That's right. And today we bring him on to discuss rollups and how should founders be thinking about the types of rollups there are in the space, along with why rollups and why layer twos. And finally, to talk about how does zero knowledge or zero knowledge proofs fit into this entire rollup space. And before we get started, Qiao, do you have anything to add?
I really want to share some of the empirical data that we've been seeing, both the public data as well as the private data that we have. Remember 10 episodes ago, we talked about the competitive landscape of the various layer ones and layer twos. And we shared a bunch of data that we have that typically people don't have in the public, which is the Alliance applications data. So we're able to see sort of the live real-time developer activity of various ecosystems. And we said that these data sets tend to be really good leading indicators of how the layer ones will perform in the near future. So some of this data, some of the behind the scenes, comments we've heard from founders, love to share those.
And maybe just to add, we're starting to hear more about like rollups as a service. And so, should founders be thinking about deploying their own rollup or app-specific rollup versus on a general rollup chain? And so just to get started, what is rollups? How did it get started? Well, I think it started around, it could be traced back to 2014. Joseph Poon and Thaddeus worked on Lightning Network, which is a scaling solution for Bitcoin. And the idea was similar, which is like, could we allow more block space to be used for other types of activities while we do general transactions on a layer 2 like service? And so the basic concept of the Lightning Networks was first started. And as Ethereum started to gain popularity, around 28, a person by the name of Barry Whitehat introduced something called the zk rollups. And the idea was, could we use zero knowledge proofs as a way to offer succinct transactions in such a way that would reduce the bloat for the layer 1 Ethereum chain?
What year was this?
This was in 2018. This was around the last bear market. If you remember OMG Network and or Plasma Group, they had raised via ICO, at least OMG raised via ICO to offer, I believe it was first state channels, right? Correct me if I'm wrong, Fouda.
Yeah.
Or was it plasma channels? Sorry, plasma channels.
Yeah, there was many competing solutions proposed at this time. There was static channels, there was plasma. Plasma was a hot thing back then. And then everything was kind of put to the shelf to scale Ethereum through sharding. So Ethereum 2.0.
Yes.
And Ethereum 2.0 itself, it changed to this, like kind of skip sharding completely and like focus on rollup as a rollup centric view. So it's a rollup came as a series of evolvement of different ideas.
If I recall correctly, optimistic rollups also came around the same time, the same era. And it just so turns out that all these state channels, plasma, even sharding on the layer 1, these never came to fruition or at least widely adopted. And, it seems like over time, the two remaining scaling efforts are zk rollups and Optimism rollups.
Yeah, so a group by the name of Plasma Group, or Plasma, which was led by Jing and a couple other team members, which is now called Optimism, started with optimistic rollups or Optimism. And so what is rollups? Maybe Fouda, if you want to give a quick primer on what are rollups and why do we need them in the space?
Okay, so like the rollups and Plasma and side chains also share the same philosophy, which is that you have limited capacity on the L1. The L1 cannot have many transactions. It has limited throughput. So the concept here is, let's take some of this transaction and execute them off a chain or in a different chain, that we can actually be faster, we can have more capacity. And once we execute this transaction on an off a chain, let's tie them back to the L1 so that no one can steal this money when you take it off a chain. So the rollup is simply like you take a bunch of transactions, you execute them in a rollup, and when the rollup executes these transactions and do all the activities that you want to do, but every block, they kind of push back a proof in the case of zk rollups, and they also push a compressed version of the transaction data back to the L1. And then you can actually scale Ethereum this way. And today, actually, like we achieved this vision because rollups now actually have 3x the throughput of Ethereum. Like the universe of rollups in general have 3x the capacity of Ethereum itself.
It's not very much, to be honest. 3x.
Yeah, we are just starting. Like we have the first two zk rollups launched last 2 weeks. So like we are very, very early in this game. But according to Vitalik's view, this will keep growing, and Ethereum eventually will be just a layer to settle up the proofs that are pushed from the L2s. So Ethereum may not be even used for smart contract anymore, or like for applications like Uniswap. Everything will move to the L2, and Ethereum in the long term will be the settlement layer for this all L2s.
And just to double click on what Fouda mentioned around what rollups are essentially a way for transactions to be computed that isn't using the layer 1 resources. And what it does is once it computes, once it's finished, it sends the verification proof and it'll submit it to the Ethereum layer 1. So then Ethereum layer 1 knows that this transaction has been completed off chain. And the result of that would then be published so that Ethereum layer 1 can verify that transactions have been completed.
Fouda, just to dive a little bit deeper on that. So basically, the way that the layer 2 interacts with the layer 1, you said two things. One is posting the proof on chain, right? And the other one is posting a compressed set of transactions on chain.
Yes, that's correct. Mm-hmm.
And that will incur some cost on the layer 1, right? Because these two things need to be stored on the layer 1. Between these two things, which one incurs more costs?
As of now, the data storage, because the amount of data you store to the L1 is higher than the amount of compute you need to verify the proof. And something like optimistic rollups doesn't have actually the cost of validating the proof. So in Optimism, for example, all the cost comes from storing the data. So in optimistic rollups, it's only data cost. So yeah, this is the largest factor. That's why Ethereum community is trying to move to this blob space to save or reduce the cost of this data storage.
Yeah.
And maybe we can touch on like data availability layer, blob space, which is the IP4844 a bit later. And we can go into like Celestia and Egan layer. In regards to just the roll-up space, there's Optimism and there's Arbitrum. And so they're, in terms of infrastructure, they're a bit different. And so before we dive deep, what is the difference between an Optimism or optimistic rollup and a zk rollup?
So let's start with what Qiao mentioned here. You have two things. You have to send a proof to the L1, and you have to store the data. So you have two variables. Actually, changing these two variables will give you three kinds of scaling solutions: optimistic rollups, zk rollups, and Validiums. So I made it even more confusing. So in optimistic rollups, you assume that everything is correct by nature. You are optimistic. So you post the data like from the execution data from the L2 to the L1, and you say, we are optimistic, it's correct, but we will have to give some time to make sure that if something wrong happened, we will have to fix it. So this is called fraud proofs.
And what do you mean by when something is wrong?
The sequencer or the entity that is responsible for ordering the transaction on the L2 and posting this data on the L1 can cheat, can either block some transactions, can front run, or can even change the execution and say, yeah, this user sent me all this money, something like that, and submit something like that, and then
or double spend.
Yes, exactly. So any kind of attack that can be done by the sequencer can be challenged using the fraud proofs. And this is the first kind. We are optimistic, but there is a way to recourse, a way of recourse. The other way, try to avoid that, which is like zk proofs or zk rollups. Say, no, we will use the math, like very specific kind of math, zero knowledge math, to be correct by construction, which means that once we execute the transactions, we use zero knowledge to create a proof. This proof cannot be generated unless all these transactions were executed correctly. And once we have this proof, we will send this proof to the L1, store it in the L1, so such that everyone can validate it, and then also post the data. So zk rollups are the most secure because it shares a proof of correctness, which is a proof, and it also has the data availability on the L1. So Validium is different from zk rollups because they try to reduce the cost, but also reduce the security. So they send only the proof to the L1, but they store the data somewhere else.
And this could be a centralized server, right?
Yeah. Central AWS, IPFS, it doesn't matter, but it's not in the L1 anymore. So this can reduce the cost significantly, but has less security guarantees than zk rollup. So in my opinion, zk rollups is the most secure scaling solution for Ethereum right now.
It's the most secure, but also given that optimistic rollups need a 7-day or a week of fraud challenge period, it's also probably comparatively the best user experience, because with a zk rollup, when you withdraw your money from zk rollup back to the Ethereum layer 1, you don't need to wait that long. Whereas on an optimistic rollup, you do need to wait a long time.
Exactly. But at the same time, it's very complex to build a zk rollup, right? So you take the effort on the engineering side, you make something very complex, but has better user experience, which is shorter withdrawal delay.
But then what is the trade-off there? Because right now we've mentioned two advantages of zk rollups compared to optimistic rollups, right? That the trustlessness and the wait period. But then what's the downside? There's got to be a trade-off somewhere.
The trade-off is the complexity of building a secure zk rollup, because you will have to go into very specialized kind of math, and you will have to construct what we know as zk circuits, which we may touch on today as well. So it's a very complex process, very tedious. It has a lot of security assumptions. This is one. The other thing is that you need to actually optimize the proof. Like the proof is, you have additional penalty here. You post another proof to the chain, and you need to actually do some computation to validate this proof. So this proof has to have certain parameters. It has to be small in size because you pay for storing it on the L1. It has to be easy to verify this proof. So this is the main downside for zk rollups, the proof part, that you need to validate this proof and store it.
And just to add some context, there are different types of proving systems, right? As you mentioned. Mm-hmm. And these proving systems are essentially ways, there are different trade-offs in regards to how they compute the zero knowledge proof, and then being able to store it onto, let's say, a layer 1. Mm-hmm. There are probably 5 different or popular zero knowledge proving systems. There's zk-Snarks, right, as one. Mm-hmm. There's Pickles, there's Airstarks, Plonks, and I think those are the ones, right?
Yeah, so actually, there is now, because zk, since the invention of proofs or introduction into practical environments in Zcash in 2016, actually zk zero knowledge is a very hot area of research. And literally every few months we find a new paper that implements a new kind of proving system. So as of now, we're probably more than 10 popular and in production proving systems, and it will grow from here. It's not gonna consolidate. But as a large categorization, we have Snark, succinct, non-interactive proof of arguments of knowledge, mm-hmm. and the Stark, which is again scalable, transparent arguments of knowledge. So these are two major categories. Snarks started from the Zcash developers, mm-hmm. and the Starks started from the founders of Starkware. And from there, people have iterated on each side, and Snarks have now many implementations. They have Growth 16, they have Blongs, they have Halo, they have Blonkish, they have, as you mentioned, Pickles. So there are so many variants that we can spend hours speaking about every one of them.
So the way this would work is just as you mentioned. If I'm using a zero knowledge a zero knowledge rollup, I would submit a transaction. This transaction would then go to a proving system, which would verify the transaction, then generate a proof using the proving systems that we just talked about.
Yes.
And then it submits the proof or the end of the computation results onto the Ethereum layer 1 as an example.
Yes. So this is the main concept of proving, that you have a complex process called proving, and you have a simple process called verification. The proving takes a lot of computations and do a lot of math on them to create a very small proof. And once you have a small proof, anyone can do very little computation to make sure that this computation that you proved is actually have been done correctly. So yes, for the rollups, the proving is done by the rollup itself. They do a lot of computations of a chain to generate this proof. But once it's generated, they post it to the L1, and the smart contract on the L1 will verify this proof to make sure that L2 execution was correct.
And by the way, for our listeners, if everything we talked about in the last 5 minutes sounds confusing and very abstract, it's not that you're stupid. It's just that this stuff is extremely, at the bleeding edge of mathematics and computer science. I remember back in 2016 or something, in that era, Zuko, who is the founder of Zcash, said that zero knowledge proofs or zk-Snarks is moon math. And the very few people in the world actually understands how it works. And including Zuko himself, he said he didn't understand the math behind his own creation of Zcash. So if everything we just talked about sounds confusing, it's not the end of the world. I personally have a background in pure math. I studied a bunch of number theory, group theory, all that stuff in college. And when I read the math behind zero knowledge proofs, it took me a while, like a few full days of staying in my man cave and no distraction. And I still couldn't understand 80% of it. So all that to say, this is really at the bleeding edge of computer science.
And maybe let's go a little bit deeper, just for fun.
Okay. Fun for me, not Smith.
Yeah, and Fouda, you and I have chatted a lot about the differences between the different proving systems. Let's talk about the two most popular ones, right? zk-Snarks and zk-Snarks. What are the differences between the two? And why would I want to choose one over the other?
Okay. So to understand the difference, let's actually start by discussing the characteristics of a proving system. What do we need from a proving system? How can we judge this proving system is better than the other, right? So there are three main characteristics. One is that the proving is complex already, right? So try to make this proving process a little bit faster, because while you are doing the proving, your customer the verifier is waiting for the proof to be generated, right? So you try to make the proving process faster. The second part, you need to store this proof somewhere. In the rollup case, you need to store this proof on the L1, and you will pay more if you are storing more data. So you try to make succinct. You need to create a proof that is very small in size, right? So this is the second characteristic. The third characteristics is that you need to verify this proof. You need to do some computations to verify this proof. And this computation it consumes gas on the L1. So you won't make this verification process very simple. So these are the three main characteristics, of my opinion, about a proving system. There are many other characteristics like trustlessness and trusted setup or not trusted setup, programmability, privacy, even if you are dealing with private information. But let's just focus on the three main characteristics. So at a high level, Snarks are very efficient in creating succinct proofs. They can create very small proofs in size, a few kilobytes, and they can be verified very quickly. So that is the main advantage of Snarks. Earlier version of Snarks, like zk-Snarks that was developed by Zcash, was not required something called trusted setup. That initial group of people will come together to create some secret randomness, and this is not very favorable. It adds a security requirement. So that's why it wasn't very popular. In recent versions of Snarks, actually like Blanc or Halo doesn't require this trusted setup anymore. So it improved. But the problem with Snarks is that they require a lot of proving. Proving complexity is too high. On the other hand of the comparison, Snarks have two main advantages. The proving can be very fast, and they by nature trustless. They don't require trusted setup. Their main issue is that they generate larger proofs, maybe hundreds of kilobytes. So the cost of that is higher. To store this is higher. So this is kind of very high level comparison between Snarks as a family of algorithms and Snarks.
And just to add a little bit more context, you mentioned trusted setup. And a trusted setup is essentially a way to deploy a proving system that is untampered with. Because the problem here, which could be the attack vector for a malicious party, is to set up a proving system that could be altered so that you could change the transaction in a way that would be beneficial for the malicious actor. And so what you need to do in this case is set up a trusted setup, which would allow like a party of people that come together that generate a random code, and the random code has to be verified between the parties. Once it's aligned, then the proving system would then get deployed.
That's a very good summary of like the trusted setup process. It's essentially creating a secret.
Was this generated by GPT-4?
We wish, right? It would be super fun to like. But ChatGPT will give you the output, the secret writing. Like here is a secret. So
So we have the understanding of the proving system. We have a trusted setup, and then maybe one more area that we hear a lot about is zk circuits.
So people hear the words zk circuits and also the prover and the verifier. Like there's all these terms that people tend to be confused about. Let's define those, Fouda, just so people have the enough background knowledge to understand further literature in this space. What are zk circuits, prover, and verifier?
So the simplest way to explain a zk circuit, we'll have to tap into your memory from high school algebra and remember something called equations. When you have x plus y equals 0, or x squared minus 2x equals 0, something like that. So this is an equation. A zk circuit is a very simple explanation of zk circuit is that you have a bunch of these equations, like millions of them, and all of them have to be consistent. Once they are consistent, you can actually generate a proof that all these equations were consistent. That is what a zk circuit is. It's a bunch of mathematical representation or arithmetic equations that have equalities, and you have to make sure that all these equations are satisfied. And once they are satisfied, you can actually create a small proof showing that. So why their zk circuits are useful? Because using math, you can create a small proof that will be equivalent to validating millions of equations. So this is very simple, like a zk circuit. So how we use them now? So now we use smart contracts, programs, or any code. You can develop code in Rust, Solidity, whatever. So you have a smart contract, which may be hundreds of lines of code. So the advancement happens that we can actually convert these hundreds of lines of code in high-level programming languages like Solidity, and using some arithmetization or like some arithmetic tricks, convert this code into a bunch of mathematical equations. Once you do this, then you have converted your code, which cannot be proven. You cannot make sure that the code has been proven in its original format. So you perform a kind of transformation. You convert the high-level code into a bunch of mathematical equations, which we call zk circuit. And now, voila, this zk circuit can be proven. So this is what most of the work happens, like this conversion process, converting the equations or the code into a circuit.
So so zk circuit is essentially like a middle layer that communicates between the prover and then the application that's behind it, right?
Once you have the zk circuit, once you have this bunch of equations, the prover comes in. The prover comes in to make sure that all these equations are consistent, and then gives you the proof. So the prover actually acts on or works on the zk circuit.
Got it. So let's wrap this all up.
Imran, you look confused.
Not confused. I just want to make sure that our listeners understand all of these different components and how they all work together from end to end. So maybe, Fouda, walk us through, like, let's say I submit a transaction. I'm a user and I just submitted a transaction. I'm YOLOing into some shitcoins.
Okay, don't do that.
Explain to me what happens in the background within a zk rollup.
Yeah. So the beautiful thing about zk rollups is that all this moon math in Zoku's terms is very abstracted and hidden from the user. So some clever teams of engineers have done insane amount of work, right, to abstract all this complexity away. So what happens now? I will just take zkSync era as an example, which is the new product of Matter Labs. So zkSync actually, and the engineering team at zkSync have done an amazing job building a zk circuit that represents the Ethereum virtual machine, the EVM. So now it's a virtual machine, which means it can execute anything, right? So they build a general enough circuit to execute essentially any Solidity code or any code for this matter. It's a Turing complete circuit, essentially. So now this circuit sitting at the back end on a server at zkSync, and now developers will come and build smart contracts using Solidity, or even reuse the smart contracts from Ethereum. Someone can get the Uniswap code and deploy it. Done. So you as a user, you connect your wallet, point it to the zkSync era network. You use MetaMask as usual. You send the same Ethereum transaction that you were going to send on the L1, but now you send it to the L2. After that, the magic happens, but it happens somewhere else. The magic happens that this Solidity code will be converted to the equivalent circuit. This circuit will be proven. zkSync servers will generate the proof. The proof will be posted on the L1. The smart contract on the L1 will validate it, and done. As a user, you didn't see any of this happening. You interacted with...
You did a bunch of moon math, but you don't know what you did. That's the magic behind it.
Exactly, like Qiao. This is exactly ChatGPT, right? You go, type a prompt, right? Do you know what's happening under the hood? Does anyone know what's happening under? Does anyone understand the transformer model? No. That is the beauty of engineering, that you build very complex engineering systems and just abstract it. The user doesn't know anything about it, but it works beautifully. So in this case, like AI and zk are very similar. Like you can connect to zkSync or like Polygon zkEVM, submit your transaction, very similar to Ethereum, and the moon math happens, and you get more throughput, you get lower fees, but you don't know why is it, what happened under the hood. Yeah.
I love the term moon math.
It's cool, yeah, right?
By the way, Vitalik wrote an article, I think a few months ago. He actually talked about this moon math term and where it came from. And he said that, yes, a few years ago, it was indeed considered moon math, back in 2016. But at the pace of innovation in the whole ZK space, like ZK is moving so fast, and there's so much research going on, and there's more and more people who now have the knowledge to understand it and have the expertise in such a way that zk is almost no longer a moon math, because so many people understand it today. And this has been only 7-8 years since the first application of zk in crypto. And Vitalik says something to the effect of, if you have quote unquote intermediate knowledge of math, you will be able to understand zero knowledge proofs. I assume that intermediate knowledge of math means you have a undergraduate degree in pure math, and you've taken at least first year, second year course in some kind of number theory, group theory, Galois, like these courses.
Yeah. It was more math because actually the roots of zero knowledge proofs and the cryptography was like a very niche in computer science department. And this, because it has very hard cryptography, no one touched this except people who are like really, really deep in math. So it was like the geeks of the geeks who who touched zk math, zero knowledge proofs. And here is a funny story. The first implementation of zero knowledge proofs, which was Zcash, was not developed by a company. And instead, the company, the electric coin company, or that is the name of the company behind Zcash, which is a fun name as well, worked actually with researchers at university to build it together, because no one would understand how. So Matthew Green, which is a professor in computer science, was actually one of the co-founders of Zcash, because this is very hard to implement. So they worked with the university to make it happen.
Let's bring all this theory back to reality.
Yep.
zkSync, Starknet, Polygon zkEVM, Arbitrum. These are the 4 hottest things at the moment.
And zk scroll.
And scroll, yeah.
And linear. from consensus. So everyone is bringing a zkEVM now. So
two of them launched last week, Polygon zkEVM, as well as zkSync Era. One of them launched their token 2 weeks ago, and that was Arbitrum, which brought the entire chain down. that was a very typical crypto. And there was some drama around the DAO. But anyway, everyone's talking about these things. What is the current state of these 3 or 4 zk rollups? And what is the trade-offs that they're making between each other?
So Arbitrum and Optimism, just for clarity, are like optimistic rollups. So they don't follow this moon math.
Yep.
zkSync, Polygon, zkEVM, and these are the 2 mainnet zk rollups. So because optimistic rollups were first to market, like Arbitrum is now 1.5 years old, and like Optimism is another about a year old as well. So so far they are number 1 and 2 in activity. Arbitrum number 1, Optimism is number 2. Qiao, if you can find the L2 beat.
Yeah.
While you are doing that, so as we discussed, Optimism and Arbitrum are number 1 and 2. zkSync Era and Polygon zkEVM are the first general purpose zk rollups. These are not the first zk rollups in the sense. On the contrary, actually, zkSync had a product launched 2 years back, which now it's called zk Lite, which was a zk rollup, but it only had payment functionality. It didn't allow general smart contract. Similar to Loopring, which has one functionality, which is trading, and many other like limited functionality zk rollups. So the innovation that happened last 2 weeks is that we finally have a mainnet that can have general purpose applications.
And by the way, the reason for that, so you said zkSync Lite was launched 1 or 2 years ago, and which was the very specialized zk rollup. And the reason for that is because it's very difficult to write all these zk circuits
Exactly.
for a set of general purpose Turing complete functions and programs. You're going to have to write very specialized circuits for each like quote unquote set or type of functions. And that's why it took them a long time to finish writing all these different circuits. But back to the original point. So the state of everything, right? Like you mentioned Arbitrum, Optimism, which are the optimistic rollups, as well as zkSync, Polygon, Starknet, which are the zk rollups.
Yeah.
And today, if we look at the TVL of these various rollups, we can see that Arbitrum is by far the number 1. Arbitrum is actually 3 times as big as number 2, which is Optimism in terms of TVL. So Arbitrum has $6 billion in TVL, and Optimism has around $2 billion. And it's also worth noting that on this list, you see zkSync Era and zkSync Lite. So zkSync Era and zkSync Lite, one of them is the general zkEVM, and the other one is the specialized one. They both have around order of magnitude $100 million in TVL. But zkSync Era is the one that launched 2 weeks ago. And I'm actually very impressed with their growth so far. So I'm going to click into this so that everyone can see the growth of the TVL on zkSync. So this dot here, this green dot, is March 24th, which was the date where zkSync Era was launched. So it started from 0, and it's been growing very consistently until today to about $100 million in TVL. Very impressive growth. On the other hand, Polygon zkEVM also launched around the same time, right? And Polygon is actually down here with only less than $3 million in TVL. Let's assume for a second that this data is correct, because I haven't been able to find any other data sets. So let's assume that this is correct. By the way, we talked about this many times on our podcast, which is that the quality of data, on-chain data in crypto is just not there yet. So we should always take everything that we see with a grain of salt. But anyway, let's assume this is correct. Polygon now has $3 million in TVL, which is 30 times less than zk-Sync era. Although still, it's been growing pretty consistently. And actually, I was talking about this with some of our founders, and they were wondering why, zk-Sync era and Polygon EVM, despite launching at the same time, one of them is growing much faster than the other. And they said they think it's because zk-Sync era, or zk-Sync in general, has been around for a much longer time. And so developers trust them more than the Polygon zkEVM. Polygon, despite being around for a very long time, the zkEVM is their first project into zk rollup, because previously the Polygon chain, it was basically a sidechain. It had nothing to do with zk rollups. They think that people trust zk-Sync more than Polygon. In reality, I think what's happening is something really dumb, which is the fact that Polygon has launched a token already, whereas zk-Sync has not.
I think it's as simple as that.
So it's really as simple as that. Like, people are just pumping their assets into zk-Sync in anticipation of a future airdrop. And so people are really just farming the token.
Arbitrum's playbook, right?
Yeah. And by the way, this is a really funny lesson for a lot of founders. This is actually a really good reason for not launching a token, because there's an anticipation for future token launches when you don't launch the token. And for the same reason, I think that, or at least for a similar reason, Arbitrum and Optimism, despite launching around the same time, Arbitrum has been well ahead of Optimism. And I think part of the reason was because of the anticipation of token launches.
Mm-hmm.
Fouda, you seem unconvinced. What are you thinking?
Arbitrum launched quite before Optimism. So by the time Optimism came to mainnet, like, there was already a ton of activity on Arbitrum. And if you remember back then when Uniswap was scaling to L2s, they communicated the plans to launch an Optimism. But because Optimism was not ready, they made a quick vote, and the community actually voted to launch Uniswap on Arbitrum first. So Arbitrum was first mover, and honestly, at the technology level, they're still the first mover, because at least they implemented the fraud proofs, which Optimism is still working on. So I think also zk-Sync, but so it's time to market, which also plays in the zk-Sync, zkEVM from Polygon. zk-Sync was first to market. They had actually a product. And if I'm a developer and want to deploy my protocol, I would likely go to zk-Sync era, because I will be the first mover there. I will get more attention. But if I'm considering Polygon ecosystem, I will launch in Polygon BOS, because that's where the liquidity is. So there are different variables. That's how
Speaking of first mover advantage, I want to just mention a quick anecdote, which was mentioned by Anatoly, the founder of Solana. So Anatoly came to our cohort and spoke in front of our founders a couple of weeks ago. And he talked about how Solana really out-executed all their competitors in the 2020 era, despite having raised 1 or 2 orders of magnitude less money than all their... do you remember, there was projects that raised $100 million at a $600 million valuation?
Yeah.
In the 2018 era without a product. Whereas Solana, guess how much Solana raised? Solana raised less than 10. That order of magnitude, 1 or 2 order of magnitude less money than all their competitors.
And they got 100 passes before they got a yes. I remember.
They got 100 passes. And I know that, I actually know this from a lot of VCs who pass on Solana, saying, so one of the VCs says, Anatoly, you seem like someone who is a little bit too laid back for a founder, for an entrepreneur. And there's other people who said, you only raised $5 million. How are you going to compete with those who raised $100 million? So they pass on Solana for these reasons. But anyway, the story that Anatoly told us was that they out-executed everyone else simply by being the first to the market.
Mm-hmm.
All the competitors, Solana was still building, was still on testnet, marketing for 100,000 TPS, where Solana just didn't care, just launched the mainnet in 2020 and got some of the major market makers on board, including Jump and FTX. FTX, obviously in hindsight was a bad, I guess, incident for Solana, but it's undeniable that FTX played a pivotal role in terms of bootstrapping the critical mass of developers in the early days of Solana. So back to our point, the first mover advantage is actually ridiculously high. And same story with Polygon. Polygon back in the day didn't have very good technology. It was a zk rollup. It was not even an optimistic rollup, but it was the first to the market, and they marketed themselves as the scaling solution for the Ethereum community. Even if they're not relying on security, the underlying trustlessness assumptions of Ethereum Mainnet, Ethereum L1, but they were first to the market.
And it goes back to like Amir Halim's quote, if you remember, that Vinod Khosla gave him, which is like, if you're a startup founder and you're building in the space, your goal is to survive no matter what. And if you survive long enough, then luck can play to your advantage in a way that'll help you become successful. And so I feel like it's also partly that, right? It's like, if you're first mover's advantage and you continue to stay and build long enough, luck will play to your advantage as you're like scaling up and growing your user base. Fouda mentioned recursion. Mm-hmm. And so what is recursion?
So you mentioned that zkSync used Snarks, which is specifically Plonk, and Polygon zkEVM uses actually both Snarks and Snarks. So you asked a very valid question. How can you use two different proofing systems?
Yeah.
So Polygon zkEVM uses the concept of recursion, which is you take some data or some transaction, you generate proofs for each one, and then you aggregate all these proofs and create a proof for the proofs. So you can create this recursive loop. So what Polygon is doing, Polygon zkEVM is doing, is that for every transaction they generate a Snark, and then they aggregate these Snarks into another Snark. So they have two layers of a Snark. But the problem with the Snark is that it has large proof size, right?
Yeah.
We discussed this earlier.
Yeah.
So as the final stage, they use a Snark to prove the Snarks, which voila makes this proof size smaller, and they can submit this small proof on the L1. So Polygon zkEVM has done really good tricks in engineering to do recursion between Snarks and Snarks to be able to kind of check all the boxes by engineering. So
is this the same idea behind the so-called layer 3s? I don't know if you've seen this narrative, but it seems like layer 3s is also recursive proofs. So the layer 3s post proofs to the layer 2, the layer 2 verifies them and posts a proof of those proofs to the layer 1.
Yes and no. So yes, the concept is correct. Like when you do recursive proofing, you can do that. But the fun fact is that you can actually do this in the layer 2. Why do you need a layer 3 if you can do recursive proofing? So you don't need a layer 3. So I think layer 3 is more to add more features that are not available in the L2. Let's say zkSync now can do proving, right? But it doesn't support the privacy. So what if you want to add privacy? You will not go and rebuild the L2. Instead, you go build an L3 that has privacy, and you will create the proofs that maintain privacy. And now zkSync can actually roll this into their own proofs. But again, just to be clear, not all proving systems support recursion. So there is still a lot of work to be done to assess the viability of L3s.
Is the idea between this mashup is it just for data compression? Like, why would someone want to use both Snarks and Snarks? Is it just primarily for data compression?
Yes. You mean your question is specific to Polygon zkEVM, right?
That's right. Yeah. Why the mashup of both? Is it just
because if you use a Snark alone, they will have very fast proving, but the proofs will be too big.
Oh, then you use
do another step of Snarks that will increase your proving time a little bit, but not by much, but will lead to a much smaller proof size. So that's why the mashup.
And it's only 2 minutes, right, to do the computation?
Yeah, they have done a really good job. So the most recent claims of Polygon team is that 500,000 of gas will be done of transactions, will be proven within 2.5 minutes. And they are trying to push this to sub 2 minutes. So,
okay, so that's a good understanding. So zkSync uses zk-Snarks, and Polygon EVM or zkEVM uses Snarks and Snarks.
Yes.
One is EVM compatible, which is Polygon, and the other is, I believe, bytecode compatible, right?
Yes.
Okay. So let's talk about the differences between the two.
Yeah, we haven't touched on the topic of EVM compatibility. Actually,
Yes.
Vitalik has a really good article here, and he created some of the terminology which we are using. So
talk about what EVM is, and then
So Vitalik defined 4 different kinds of zk-EVM, or like circuits that can be EVM compatible or not compatible. Okay, so let's start. What is EVM? EVM is the Ethereum virtual machine. So that's a virtual machine that can execute any code, but it was created with a specific syntax and specific logic. So you have a chance here when you're trying to build a zk rollup. You have an opportunity. You can tweak your circuit to be exactly compatible with the EVM. So this is 100% zkEVM equivalent or compatible. So Vitalik calls this type 1 EVM. On the other end of the spectrum, maybe when you try to do this equivalence to the EVM, your throughput gets affected.
Mm-hmm.
So instead, you can build actually a very efficient zk circuit that are general. You can, let's call zkEVM, we'll drop the E here. So you have zkEVM that can execute any logic, but it's way faster because it doesn't commit to the EVM structure.
Mm-hmm.
And this can be very fast. So this is what zkSync went for. zkSync went for this, and Starknet specifically, they went for this type 4. They built their own circuits that are very general, but it can be very performant. It can have thousands of TBS, like the target is at least 2,000 TBS. But the problem is that this is not compatible directly to Solidity. Like developers who develop for Solidity, they will have to learn a new language. So what zkSync done, and I think they have done great in this regard, that they created a lot of software layers or middle layers that can actually take Solidity code, high-level Solidity code,
mm-hmm.
and compile it to the architecture that works for them, to their own zk circuit. So now, actually, you can have Solidity code that you wrote for Ethereum before and deploy it in zkSync era. Yes, it's not compatible to EVM, so you cannot just have the bytecode and run it in zkEVM, but the zkSync era will take the Solidity code and compile it to the correct architecture.
So we talked about the TVL, right? The change in TVL.
Mm-hmm.
Do you think builders are choosing zkSync because it's just much more faster? I mean, what's the throughput on Polygon zkEVM? Is it 3x faster than a layer 2? A traditional optimistic layer 2?
So Polygon zkEVM can have like hundreds of TBS, like TBS in the hundreds, maybe 1,000. But I think zkSync will always be faster because they optimize the circuit for this reason. Like,
how much faster?
I would say, like, again, both are trying to improve, but I would say as of now, it's like between around 3x or 3 to 5x faster than zkEVM. But anyway, none of them actually running at maximum throughput right now. So if we go back to the chart that Qiao showed from L2 Pete,
mm-hmm.
like both of them are running at sub 10 TBS. So
interesting.
The theoretical maximum is not there yet.
Right now, if you look at this website called l2fees.info, which is another pretty popular website that people look at. Again, I don't know how accurate the data is. This one should be a lot easier than TVL to get right. But Polygon zkEVM, the fees on Polygon zkEVM to send ETH is 23 cents right now. And to run the same transactions on Arbitrum 1 is 15 cents. So Arbitrum is actually cheaper than Polygon zk. And then the data doesn't have zkSync era, but it does have zkSync Lite. I suppose zkSync era might be a little bit more expensive than zkSync Lite. Fouda, what do you think? Is that the right intuition, or because zkSync era tries to do something more general purpose?
I think it will be in around the same ballpark of zkSync Lite.
Okay, so let's assume that it's in ballpark as zkSync Lite. It's only 10 cents. So zkSync Lite today is cheaper than Polygon zkEVM, if that answers your question, Imran. But again, like there's so many other factors at play here.
Yeah, agree.
Right, like the number of transactions that are happening today, like haven't reached the capacity yet. So that's one factor. The other factor, I think, Fouda, you mentioned this earlier, which is that the more transactions you run on a zkEVM, the cheaper it is for each transaction because there's a fixed cost, right?
Yes, it's a counterintuitive because we always go to the mentality of like more transaction means more competition for block space, which means naturally more fees, right? But because rollups actually have to generate proofs, and these proofs are fixed cost. Like once you send a proof, this proof can prove one transaction or can prove 1,000 transactions, right? So the more transactions you put in the proof, the cost of this L1 cost will be amortized or be shared between these 1,000 transactions. Yeah. So at a certain scaling limit for zk rollups, the more transactions you get, the cheaper the cost will be until you get to this limit, and then it will be kind of fixed cost from now on.
My takeaway from looking at this data is today, the layer 2s are all in the same ballpark in terms of transaction fees. And they're all about 5 to 10 times cheaper than Ethereum layer 1, but they're all more expensive than Solana. This chart doesn't have Solana, but Solana transaction fees is basically zero. So even the Ethereum layer 2s today are 1 or 2 orders of magnitude more expensive than Solana. And again, I want to share the insight from Anatoly's talk. By the way, I'm not shilling Solana versus layer 2s or vice versa. Just sharing the things that we've heard. The insight as to why Solana works and is cheaper and is really, really cheap is because Solana builds the parallelization into the VM. There's built-in parallelization, meaning when the developers writes a Solana code, they have to, if they want to write it according to the rules of Solana, they have to parallelize some of the transactions. Whereas on Ethereum, the way Ethereum layer 2 scale is basically parallelization via L2s. So what that means is on Solana, you have a bunch of transactions, but they all parallelize natively. Whereas on Ethereum, you have a bunch of transactions, but they all parallelize because there's a bunch of independent layer 2s. This is the insight behind Solana being really, really cheap.
Another interesting thing about Solana is they launched something called the account compression program. I don't know if you saw that, but essentially this program is used to, right now all the data is stored on chain, right? Now they have a compression program where you could store the data off chain, and then it produces a Merkle root or Merkle tree that would be then stored on chain via, it's called like a fingerprint. And then whenever the smart contract has to call that data, it can use this account compression program to do so. And so an interesting experiment they launched recently was being able to mint 1 billion NFTs within a minute. And, and they actually did it, which I thought was very interesting.
I think this is similar to the concept of Validium, when you have the data of a chain.
Exactly.
And they can now reduce the cost of storing the data on a chain. But yeah, like the discussion on fees between Solana and L2s is interesting because Solana, like the counter argument is that Solana doesn't have a fee market. Like you cannot compete for priority in transactions.
I think they started a fee market.
They started, but it's not well ingrained yet. So
yeah,
they intentionally like kept small fee for everyone, which according to Anatoly, it was a minimal fee. Like other than that, it doesn't work anymore. Under that, it doesn't work anymore.
Yeah.
We talked about TVL and fees. There's another data set that I wanted to share, which is our Alliance application data, because it's a pretty good indicator of where the developer activities are. So we said Arbitrum is ahead of everyone else in terms of TVL. In terms of fees, same ballpark. Maybe zkSync in theory will be cheaper than Polygon, and zk rollups in general will be cheaper than Optimism rollups. But in terms of developer activity, what we observed over the last few months is that there was a very big event, which was the collapse of FTX in November last year. And ever since that, we see that Arbitrum and Optimism are growing in terms of developer activity at the expense of Solana. Now, the rate of change, the delta isn't that big. So it might be a few percentage increases for Arbitrum and Optimism and a few percentage decreases for Solana. But this is a trend we've seen so far. But still, Arbitrum, Optimism, Solana are in the same ballpark. They're still way ahead of everyone else. And Polygon is still also up there. So I would say today, Polygon, Solana, they're followed by Arbitrum, which is also slightly ahead of Optimism. But then after these four, there's a long gap. There's a big gap between these four and the rest, including zk-Sync, Starknet, and all the other alt layer ones and all the other up and coming layer twos. So this is what we're seeing on the developer activity side.
Well, I guess the question is, I feel like the crypto ecosystem, they swing in certain narratives, right?
Yeah.
So there was a narrative early in the last bull market where everybody was building on Solana, and then layer twos weren't as robust as they are today. Now, because of the downfall, as you mentioned, and other infrastructure issues, the pendulum swung back to layer twos.
Yep.
And now everyone's building on layer twos, and people are now looking at Solana and saying, like, who wants to build on Solana anymore when we have all of these layer twos? And just going through all of the infrastructure around our rollups, you have rollups, then you have data availability, you have Validiums, and the list goes on. Now we have shared sequencers, which we can also talk about.
Yeah.
And so the question then becomes, how much is too much for founders building in this space, right? And would founders then find the ease of use of using Solana much more, from an onboarding perspective, much easier versus going through the rollup space? We also have rollups as a service, right? So you have all of these different complex components within the Ethereum side, and then on Solana is just very easy to be onboarded.
And then there's a whole story about the rollups as a service becoming a real threat to Cosmos. This whole space is very deeply intertwined.
Well, let's talk about rollups as a service.
Okay.
Fouda, or Qiao, do you want to run down what rollup as a service is?
Fouda, go ahead.
The concept is very simple. Actually, it goes back to maybe zk Lite. zk Lite was like zk rollup as a service essentially, but it's only for payments, right? It was cheaper. It was faster. It can be better essentially. So the concept of zk of rollups as a service is that instead of using a general purpose rollup like Optimism, Arbitrum, zkSync, or the Polygon zkEVM, and competing with other applications using the same system, why not go and build your own blockchain? And your blockchain here is your own rollup, that you own all the resources, you control the sequencing of transaction, you have the whole space. And the examples that are left today, actually like DYDX, Immutable X, Rhino-Fi, all these are actually rollups as a service. And Starkware was the one that...
Not necessarily a rollup as a service, but rollup as an app chain.
As an app chain. So rollup as a service is just taking this step further by making some development frameworks that it's actually very easy to launch your own rollup. So there are many competitors now. Most of them are actually focused on optimistic OB stack. Some of them are focused on having zk rollup as a service. But the concept is that a developer will be 5 minutes integration work, 5 clicks, and you get your own rollup with its own browser, with its own RPC node out of the box. So this is the concept of a rollup as a service.
Remember almost a year ago, we said on this podcast that rollup as a service and Cosmos, the two visions are converging. And indeed, today they're converging. And matter of fact, I think the rollups as a service on Ethereum is a massive threat to the whole Cosmos ecosystem, because we know for a fact that there's several fairly mature DeFi protocols that were previously looking at Cosmos to launch their own app chain. Today, they're looking at a rollup as a service or rollup as an app chain to launch their own app chain on Ethereum as opposed to Cosmos.
You can also have both, by the way. You can have a rollup as a service on top of Cosmos, so like Celestia. and so you can have everything if you want. Like, as you mentioned, everything is intertwined.
Again, back to Imran's previous point, like how much is too much, right? Like this is way too much for new founders. Like what the hell is going on and how do you choose a chain to build on top of? I think there's actually a few simple rules or actually some simple trends that we're seeing. So rollup as a service is probably not something to think about when you're new, because these are for mature projects. Okay, rollups as a service and Cosmos, they're all for mature projects. But we're seeing some trends between Arbitrum and Optimism. Again, these are things that you probably can't find online, but things that we hear behind the scenes. Arbitrum seems to be the hub for DeFi. The likes of GMX and Imran, you've tried a bunch of derivative trading protocols on both Arbitrum and Optimism. And you can tell us which one is better. But it seems like Arbitrum has most of the volume at the very least. And that's where the users are.
I mean, the volume on, both open interest and liquidity, the UI UX on products are just so much more robust on Arbitrum than it is on Optimism. I've used a couple products on Optimism, and I mean, it's okay. It's not amazing.
So Arbitrum is a DeFi hub, the DeFi rollup. Optimism seems to be attracting a bunch of gaming developers due to their, I guess, connections with some of the OG gaming projects and their friends. The Ethereum Foundation, the 0x Park, Dark Forest, like these guys. So it seems like a lot of new gaming developers are choosing Optimism just because everyone else is choosing Optimism. That's a very interesting trend. We're also hearing things about Starknet. It seems like some of the Starknet developers are a little bit discouraged by their migration towards Cairo 1.0, which is taking a while, number one. Because they acquired a bunch of developers to build on top of Starknet, but the current version of Starknet is just not very cheap. It's only a quarter of the fees of Ethereum Layer 1. And so they're going to migrate to the next version, which they call Regenesis. But it's taking a while, and then also developers would have to rewrite their whole code. So there are some talks there, some disillusionment in that side of the world. And then you have Polygon, which is, we mentioned before, the beast in terms of BD in crypto. They're by far the best BD team in the entire layer 1, layer 2 space. But yeah, so these are some of the, I guess, data points that founders can think about when they think about choosing which. And there's also Solana, which we talked about last time with Amir. And the reason why Helium is picking Solana over any of the Ethereum layer 2s is simply because Solana is 2 orders of magnitude cheaper. There's simply no way for a proof of physical work project where a user earns, let's say, $5 of tokens per day and having to pay 25 cents in fees. That just eats into too much of the margin.
He also made a direct comparison to AWS. If you remember, he goes, what's the point of me running my own validators, my own protocol, launching my token, etc., if I could just use something off the shelf similar to AWS? And I think that's where the rollup as a service model is, I guess, going in terms of making it easier for any founder to build their app. Don't worry about the infrastructure. We'll take care of it. Just launch using our product. It seems to be the case for me.
It seems like the rollups and the alt layer ones are all specializing. That's the point I'm getting at. Or they may not be doing it intentionally, but some groups of developers and founders are gravitating towards one over the other.
But the issue with this, obviously, is cross rollup communication and fragmentation of liquidity.
I know where you're getting at. The sequencers. The decentralized sequencer network.
Yep. There has been some talks. I just saw 2 announcements just the past 2 days. One's called Astria. I forgot what was the name of the other startup, but essentially they're creating a way for sequencers to be decentralized within different rollup space. And so now you have rollup as a service. And I'm hearing this question a lot, actually, which is we have a couple rollups as a service startups in our current batch. One is called Caldera, which is specifically around the Optimism framework. And you have Snapchain, which is primarily around the zk framework. And when we talk to these founders, they're like, well, our customers are asking us for our service, but they also want to understand, like, how do they decentralize their sequencers? They don't want us to own the sequencers, obviously, and us to run the transactions, but they also don't want themselves to do it. They want their customers to know that these transactions are batched and being executed trustlessly. So how do we solve that, Imran? I mean, there's some trade-offs that I've talked through, but now with the launch of Austria and others, they could solve that issue. And so maybe Fouda, talk us through why do we need decentralized sequencers and how important is it for maybe cross-chain comms and messaging and et cetera?
Let's start by the board sequencer. Why it's called the sequencer? Why is the sequencer
What is a sequencer?
Yeah. So like in any blockchain, you have the validator. which do two tasks. First, to order all the transactions, and then to make sure they are correct, right? In the L2s, you don't need the second part. You just need to order the transaction because the L1 will validate them if they are correct or not, or do the consensus. So that's why the terminology is different for the L2s. So sequencer is what the entity that organizes the transactions of the L2s.
Mm-hmm.
So the problem is that decentralizing sequencer will come to the same problem that we have in the L1s, which is that you need to achieve consensus between different players. And this is too much work to implement. So most L2s have already their hands full with the development of their core technology, whether it's Optimistic Rollup or zk Rollup. So every one of them is using a centralized sequencer. And the entity runs one server that organizes all the orders all the transactions.
I mean, isn't that an issue?
It's
or is it just that we trust Optimism and Arbitrum and like we shouldn't have to worry?
It's an issue, but it's not on the hair on fire issue, right?
Okay.
You need to implement the product first, right? You cannot go and build everything at the same time.
Because if the issue is if the sequencer cheats, you can get your transactions blocked, censored, but you won't lose your money. Like your money is still yours. So that's why it's not a hair on fire problem.
Exactly. So you can actually sometimes in Arbitrum or like zkSync, you can actually claim your money back on the L1, even if the sequencers are dead or like off-chain, offline. So anyway, the problem with that model is very simple. And you mentioned, Imran, that every rollup is its own universe. It doesn't speak to anyone. You lose composability, right? So Optimism team actually came with this idea of, can we actually allow different rollups to speak to each other and have atomic composability?
Was it called Bedrock? Bedrock framework?
Bedrock is the implementation of Optimism, as the OP stack.
Yes, the
so
OP stack.
The Optimism team came with this concept of super chain. What's a super chain? That everyone will build their own OP stack rollup or OP rollup, but they will share the sequencer. Like a sequencer will be sequencing all these rollups, and they can order transactions from different rollups together so that you can actually send money from rollup 1, receive it on rollup 2 in the same transaction. So that's why shared sequencer can allow actually this atomic composability. But as of now, Optimism suggested this as an idea. They haven't implemented it. But many smart teams found this idea and just ran with it. So Astria is one of them. Like they are trying to build this concept of shared sequencer. But so far, they are not focused on Ethereum. Just to clarity, Astria is focused on using Celestia as data availability and focused on the sovereign rollup space, which we didn't touch on today. But many other solutions, there is a company called Espresso, which is trying to do this for Ethereum. So the concept is simple. We will have this network of sequencers. Maybe all of them share a token, and they will be slashed if they cheat.
And yet another token.
Of course, like the concept of our space. You scale by adding more blockchains, and each blockchain is a token. So like more blockchains, more tokens. It's the wheel.
Wait.
The way our space scales is by creating more blockchains, and the way we acquire more users is by launching more tokens. That's how space works.
So a rollup for a token, sequencer token, mainnet token, data availability token. Okay, got it.
So yeah. So Celeste and data availability is a token. Celestia has its own token. So like, yep.
By the way, I think the only token that is really, 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 really needed, absolutely necessary, critical to the product is the Ethereum layer 1.
Yes.
Yeah.
I mean, really, you could probably run everything else without a token, right?
I mean, Arbitrum ran without a token.
That is the thesis of Eigenlayer. Eigenlayer is trying to use the same token for everything, kind of.
Wait, we talked about all like rollups, but we didn't really talk about data availability, and we mentioned this word a few times.
Mm-hmm.
And so maybe
this is
explain to it.
No. This is
I mean, I really don't want to go down this rabbit hole.
By the way, I don't mind. I can just keep talking about that stuff for hours, but like that would be too long.
So there's two types of data availabilities, right? There's firms or companies that are building the space, Celestia and Eigenlayer. Explain to us what is data availability.
So we agreed that every rollup need to make the transaction data available, because if the sequencer goes offline, how would we make sure what happened? What is the activity? What is the history of activities that happened on the L2 or the rollup, right? So you need to make this transaction data available somewhere, right? Mm-hmm. So this is what we call as data availability. Where is this data will be available? So if you decide to compress this data and put it on an L1, then you have this best kind of data availability, because we assume that Ethereum L1 is always up, anyone can access it. So this is the best kind of data availability. But Ethereum is still expensive. So other chains came like Celestia saying, we don't need to use Ethereum. Ethereum has execution and has storage. What if we create only a blockchain that only does storage? It doesn't do execution. So Celestia as a concept is trying to do, we're building a blockchain just for data availability. Any rollup can just throw their data at
I mean, any
Celestia.
layer one too, right? I mean, it could be any.
It can be anyone, but like essentially it's made for layer twos, because layer twos is where you need data availability. You cannot have an L1 with its data sitting somewhere else. It wouldn't work. So L1s have to have their data.
Oh yeah, you're right.
But L2s can put their data somewhere else. So Celestia came with this concept of let's separate storage from execution. Celestia will be only for storage. Execution can happen somewhere else. It can happen in Ethereum as well. It can happen in something like Fuel. It can happen somewhere else. But as a rollup, you will push your data into Celestia, and they give it a name, Sovereign Rollup. And you can decide also to have this data availability layer on your AWS. And this goes back to the Validium concept.
What I like about Celestia is that they have something called data availability sampling, where they actually like shard the data into different nodes. So if one node goes down or something happens, they can still retrieve the data.
Yeah, this is like more discussion about how to show also that like the data is available. Like no one can withhold the data. Because in Celestia you have validators who will maintain this data, and if you need access to this data, you need to ask the validators to give you this data. How to make sure that no validator can withhold part of the data. So the data sampling is an approach to reduce the dependency on certain players to withhold the data.
So in this vision, this separate data availability vision, you have three components. You have Celestia or another DA layer, you have the rollup, and you have the Ethereum layer one. So then the layer two, the rollup will do the execution. The DA layer will store the transaction data. And the Ethereum layer one, what does it even do? Does it just verify the proof?
Exactly. It will verify the proof and achieve consensus that the execution was correct. So how would you make sure that, yes, the transaction data is fixed, is stored somewhere, but how will we make sure that this transaction actually got executed? And what is the final state of the rollup after the execution? So consensus is actually validating the state or the state root. Like, where are we after executing these transactions?
The trade-off of this vision is making is trustlessness, right? Because now you're storing the transaction data in a new chain, a new DA layer. You're no longer relying on the trustlessness of Ethereum. So you add a new trust assumption.
Yeah, Vitalik has a really good argument against this separation of data availability. It reduces the security significantly here.
Yeah.
So it's similar to like kind of the world we live in today with Amazon, right? You have database, you have compute, you have storage, and all of the other infrastructure it provides. And similarly, it seems like with Ethereum, rollups, data availability, and all of the other things that are coming around, it's similarly like kind of like breaking that into its own core components. And it has infrastructure behind that powers it so that's very efficient for the end user. Is that the right analogy?
I would say it is, but the problem is that when you go to AWS, all of these are offered as services in the same platform, right? It's a click of a button, you commission a database, you get EC2 nodes, you're doing all of that, right? Now you have to use different chains. Each chain requires payment in its own token. So there is a lot of developer friction. So you will essentially need over time like platforms that abstract all of that. This is actually can be also the rollup as a service, because they kind of try to abstract this complexity. So once you launch your rollup, we will take care of everything. We will use whatever data availability layer that you want. We will pay them. We will use whatever consensus layer that you want, and we'll pay them. So this can be part, or it can be specialized layer that actually platform as a service.
This whole data availability layer, as well as the previous thing, which was the decentralized sequencer network, these seem still very much far out. Like I've been speaking with people who are really in the weeds of building these things, and they all tell me it's way too early. And so I think the reason why we're talking about these things is because you should be aware of the future, but these are not like hair on fire problems yet. Like, for example, like Arbitrum Optimism are not even, they're still running a centralized sequencer. But we want to talk about the future. What other visions of the future do you see on the rollup side? Because one thing we talked about, Fouda, which something we discussed recently, and it seems like you and I are on the same point, are on the same page, which is that zk rollups will probably need to specialize in the long term. Do you want to talk a little bit about what this vision means?
If this is space to grow and like really get mass adoption and people are using our products or this blockchain in any everyday use cases, then the throughput of any L1 or any general purpose L2 will not be enough. So this is the thesis. Like if we got adoption, no matter how many L2s you will need, so eventually you will need every app or every protocol to run on its own space that can have full potential. It can have 1,000 transactions per second at zero fee or almost negligible fees, which means that you need to specialize. So it is the same thesis as app chains. Everyone will need their blockchain essentially. But to some extent, rollups reduce a lot of complexity around having your own chain because you can commission the security and data availability from someone else. Our thesis here is that if you are running a successful product and you have a lot of users, you will try to specialize. You will have your rollup. And if it's a zk rollup, which I think will be the standard of trust because now it's correct by construction, you will have to optimize your zk rollup. What does it mean? It means that instead of using a general purpose circuit that can do any instructions, you will just create a specialized circuit or a specialized zk circuit that will do this functionality only, and they cannot do anything else. This will lead to much faster proving time, much smaller proofs. It can and lower fees for your users. And then comes a question of data availability. Let's assume that the blob space will be implemented at this time, and you will not pay too much cost for the data storage. So that means that like if you are running an order book exchange or are playing a really on-chain game, then that requires at least 1,000 TPS. Then you can build this. You can have someone who will create the circuit for you, and voila, you have your own space. You have the security of Ethereum as an L2 or even L3, and your product is running in a decentralized fashion.
Do I hear zk-Circuit as a service?
Yes.
It's a joke, but
that's in a sense what a zk rollup as a service should do on the long term.
Yeah.
Now they can just use any tech stack available, like zkSync or Polygon or whatever. But on the long term, they will have to really go into the weeds and you need this application. Here is a circuit that does that and only that.
So the zk-Circuit communicates with the proving system, right?
Mm-hmm.
And is the idea different proving systems would allow different types of zk-Circuit implementations? And that would then be the types of applications that would be in need of those types of like guarantees, right? So an example of this trustless setup versus trusted setup, one being proving speed or the cost of storing the data, etc. Is that the idea?
Yes. And we're already seeing this. Like we have a company that is like building a zkEVM, zk machine learning, right? So their rollup or their L2 will focus on executing machine learning models. So you will have kind of AI on a chain.
Which is a very special type of compute, which is a bunch of matrix multiplications versus a general purpose EVM, which can do all sorts of things, right? So in that case, it's basically a roll-up for a bunch of matrix multiplications, and they would write very specialized circuits for that kind of compute.
Yeah, this circuit will not be useful for anyone else, but it's very, very useful for this use case.
Yeah. And there's also like actual production examples, like Loopring, like, you mentioned order book-based decentralized exchanges. They will probably need some kind of specialized zk circuits at some point versus taking it from Starkware, right? Like as a white glove service, right? So point being, we think that zk rollups will specialize over time in order to provide faster and cheaper computes.
Would that mean then rollups as a service could be threatened? Because I feel like every app will want to have, if the edge is providing a quality product with UI, UX, speed, all of that, would then the idea then mean that, founders should be thinking about zk circuits, or is this the future? And rollups as a service is just a short-term hair on fire problem.
Rollups as a service, they can aggregate all these different like specialized rollups, zk rollups as well. So it's like it's a layer on top of a bunch of different rollups, including optimistic rollups, including zk rollups, including like specialized ML rollup, ML zk, etc.
Got it. Cool. Well, I think we've covered a lot today. Any final words?
I feel like we can easily break this down into like 10 episodes.
Yeah, maybe we should.
We should at some point. We could spend a whole episode just talk about zkML.
Yep.
That would be fun.
Great. Well, thank you so much for joining us. Hit subscribe if you haven't. We'll talk to you guys soon.
Thanks for listening to Good Game. Don't forget to subscribe. We'll see you next week.